Okay, good morning, ladies and gentlemen. Today we're going to be looking at last lesson of the week, 6.3. It's actually be called graphing piecewise functions. However, please, between today, tomorrow is pretty much a catch-up day, work day for you guys to get stuff done that you haven't had done. Please make sure you're sending Mr. Myers and myself your work. 6.1 day 1, 6.1 day 2, 6.2, and today's lesson 6.3 by Monday night. Thank you for your cooperation. I truly mean that. A lot of people are turning their stuff in regularly. A lot of people are not. Don't forget, next week is the last week of the semester. Monday we're going to have another lesson. Tuesday a quiz. Wednesday is the final exam. Virtual people should be picking up their packets that they've been missing, as well as their review packet for the final exam today and tomorrow. And then we're going to have our final exam next Thursday. And remember, that's 10% of your overall semester grade. It's really important. Make sure you get it done. Today's lesson is graphing piecewise functions. And the last couple days we've been graphing. We've been using Desmos. No using Desmos. This is all freehand graphing. It's important stuff to know how to do. This first page of your notes, the West Nile virus, after we talk about piecewise functions, this is just going to be an extra credit. I'm not going to go through this. This whole page here is going to be extra credit. You can kind of see, hopefully right here, with how we put this piecewise regression, these three different pieces that would come through. What you need to do is you need to find the actual regression of the first, the second, and the third piece, and make sure you're going to actually write those here with your domain restrictions and all that good stuff. And what you're going to do is just kind of go through here, through the graphing calculator, and you're going to graph each piece separately. You'll probably have to find each data value a little bit different. This is the data for the entire graph. So if you do this, please make sure you round to 3 decimal places on every term on your function. Every one needs to be rounded to 3. You do this, do a good job on this. You send Mr. Myers or myself a PDF of this, and you will receive extra credit points for it for the first semester yet, okay? So what we're actually doing here is we are graphing piecewise functions. Notice there is a piece number 1 and a piece number 2 on this first problem, and you hopefully you can kind of see they're going to be hitched at 0. They're going to they might come together, they might not. So a lot of people like to actually see where it's coming together. And some people like to graph a vertical line everywhere they're coming together. So this is where my graph may come together, it may be split. In the end, that red line will be gone, okay? But what I'm doing is I'm going to graph piece 1, and I even labeled it piece 1. This line here is piece 1. And what we're going to do, that's only good for x's that are less than 0. So my line's going to appear on this side. Hopefully we see it's a line. And what I'm going to do is I'm going to plot its y-intercept of 3. But notice here, when x is 0, it does not include, in that inequality, it is not including that 0. From there, I'm going to pick some pieces that are in the domain of that, say maybe -1, and I could plug them into this equation right here. And I could say, what is 2 times -1 plus 3? And that's -2 plus 3. Well, that's going to give me 1. So that's actually giving me the ordered pair of -1 goes in, 1 comes out, which is this point right here, which means why would I have plotted my y-intercept at -3? Because it's actually up here at +3. Sorry about that. It's not down there. And if I went to another one, I could say, oh, how about -2? So I'd plug -2 in there. Well, that's going to give me -4 plus 3. Well, that's actually going to give me my ordered pair of put -2 in. It's going to spit -1 out. And I'm going to go plot -2, -1. I'm going to plot that. Well, hopefully some people saw, hey, that's a line. So from this y-intercept, I can just use my slope of +2, which means I'm going to go -2, -1, and I can draw my line in there. And then that's going to be the piece on the left side, okay? So I could actually be using my slope to find a whole bunch because it's linear. I could be finding more points on that graph. So that's the left side of the graph. Now I need to do the right side of my graph. I'm going to do that in a different color. And whoop, I'm going to move that. I don't like how I just covered up my 5. So that's actually really, I'm going to call that piece 2 here. So I'm going to graph this one. Notice it has the equal to it 0. So if I actually put 0 in there, I get the point 0, 5. And it includes, with my inequality, it includes that. So that's going to be 0, 5. 1, 2, 3, 4, 5. That's going to be a closed dot there. And then from there, this is only good for x is greater than 0. So this line is going to go that direction. Okay? So from there, I can just pick more pieces in the domain, like 1 and 2, and I can find, hey, what do I get when I put 1 in there? Well, that's going to be 5 minus 1. Ooh, looks like that's going to be 4. And I can go plot that point. And I can do the same and say, hey, 2's in the domain of that one. So what's 5 minus 2? Well, that's going to give me the point 3. So I'm going to go over 2 up 3. Or I could look here and I can say, hey, my slope's -1. That would mean fall 1, run 1, fall 1, run 1. And I can find a whole bunch of points on here. And then I can connect those points. And that is the graph of my piecewise function. Now remember, I said this line needs to be gone when you're done. You do not leave it in your graph, but that's where it's split apart. Notice I'm just splitting a line into 2 pieces. If I graph it, well, heck, if I do my graph first, I can say, what is f of 0? Well, f of 0, I can read that on my graph. I can go to where x is 0 right up here. Oh, it's 5. Okay? Or I can take, I'm going to erase this stuff up here quick. Or I can say, excuse me, hey, where does this domain value fall into? The top piece of the bottom. Well, it includes 0, so I would put it in here, and I would say, what's 5 minus 0? Well, that's 5. That's why f of 0 is 5. I can say f of -3. Well, -3 is going to go into this top piece, so that means I'm going to say 2 times -3 plus 3. Well, that's going to give me -6 plus 3. That gives me -3. So f of -3 is actually -3. Well, I should be able to see that on my graph. I can come over here to 1, 2, 3, 1, 2, 3. There it is. And that shows me on the graph where I'm at. Okay, so I can get these values off my graph if I wish, or I can just say, hey, 2 goes into this piece because 2 is greater than 0. So I'd be like, 5 minus 2, that's going to equal 3. So f of 2 equals 3. Okay, so that's what we're going to do there, and that's all we're going to do on that one. And we graphed it and evaluated it. Next one. Next one's not too bad. Again, this is going to be 3 lines. This is 1 line, 2 lines, and 3 lines. Notice the first 2 lines might hitch at 0. The second 2 may or may not hitch at 2. So lots of people like to come in here and they got to say, hey, I'm going to have a split here at 0, and I'm going to have a split here at 2. But please remember, these lines will not stay on the graph at the end. Well, from there, what I'm going to do is I'm going to graph piece 1 in blue, and I can see, hey, that's a line. So it's going to start at 0, so if I put 0 in there, and notice it's included, so this will be plotted with a closed circle. Well, 0 plus 3 is 3, so I'm going to start at 0, 1, 2, 3, and that's going to be a closed circle. And the blue one is going to be going for x is less than 0. From there, I can pick any other point in the domain, knowing it's a line. And I could say, hey, I'm going to put -3 into there. And if I put -3, well, -3 plus 3 is 0. That's going to take me over to -3, 0. Put that point. And I can also see that it has a slope of 1, which is -1, -1 for a positive. And I can find a whole bunch of points when I graph that. And then I graph my line. And piece number 1 is done. Okay? Piece number 2. Piece number 2 is going to be in purple. And I'm going to say, here's my piece 2. Notice that's between 0 and 2. So that's going to be graphed between 0 and 2. And when I look on the left side here, if I actually put the left side into this function, notice there's no x here. That means every time it's going to output the same value, 0, -2. But because it's not including 0, I must do this as an open circle. So I'm going to say open circle at 0, -2. And then I'm going to take the other one, 2, and if I put the 2 into this function, well, it's still going to output a -2, but I include that, so this is a closed circle. So I'm going to go to that point 2, -2, make a closed point. And this is a line because it's constant, which means I just connect my 2 dots. And my middle piece is done. Then I'm going to go to the third piece here, 3. Again, this is another line. And the line's going to begin at +2. And when I put +2 into this function, I'm going to get 4 minus 1, or 3. But notice it does not include 2, so that's going to be an open circle at that point 2, 3. So I'm going to go over 2, up 1, 2, 3. That's going to be an open circle there. Okay? Now I can pick another point in the domain, meaning anything greater than 2. How about 4? And if I put 4 in here, 4 times 2 is 8, minus 1 gives me 7. Well, that's in that domain, so I can go plot 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and I can plot that. Or from my first point, I can say, hey, the slope is 2, and from my first point, I can rise 2, run 1, rise 2, run 1, rise 2, run 1, and I can make a whole bunch of points on that as well. Remember, when your graph is done, these red lines, they cannot stay on there. They need to go away, okay? Which means you just delete them or erase them if you made them. Some people like them for graphing aids, and that should be the end result of my graph right there. Now, if I'm evaluating my function, okay, well, which piece does -1 fall into? Well, now I'm going to kind of clean this stuff up for myself a little bit. I'm going to get rid of that. -1, well, where does -1 fit in? Well, -1 fits right into this piece because -1 is less than 0. So that means I got to put -1 into this one. So what's -1 plus 3? Now, that's going to give me 2. Well, which one am I going to fit 1 into? Well, 1 is between 0 and 2, so 1's going to fit into this piece. And when I put 1 into that piece, remember this middle piece here, it's always going to output -2, and I just evaluated it. Okay? Last one. What I'm going to do is, I appreciate it if you hit pause and try this one by yourself. This one's a little bit different now because now we got a quadratic and it's not just all lines. But you can see they may not be hitched here at this +2. Okay? So what we're going to do is if you hit pause, give it a shot and try it. And I'm going to be right back. Okay, so I like to graph them first. And the first piece, number 1, is for x is greater than 2. So this is going to be over here at this side, greater than 2. So what I'm going to do is, notice it does not include 2. So it's going to be an open circle when I put 2 in there. And when I put the 2 into the function, 3 times 2 is 6, minus 5 gives me 1. That's my starting point for this one. So I'm going to go over 2, up 1. And because it does not include that 2, I got to make that an open circle. Well, I can shortcut this because I know this is a line and it has a slope of +3. So from my first point, I can say rise 1, 2, 3, run 1. Rise 3, run 1. And I can make my graph really kind of fast there. Okay? The second piece, piece number 2, well, piece number 2 is a quadratic. We know that's going to be a parabola. We know it's going to open up, so it's going to be a U-shaped figure in there somehow. Okay, well, this one is going to include 2, all right? So what I would do for you right now is I would think, okay, I'm going to put a 2 in. This would be a closed dot. 2 squared is 4. So I'm going to go make a closed dot at 2, 4. So I'm going to go over 2 up 1, 2, 3, 4. That's going to be a closed dot. Now remember, this isn't going to be a line. So I want to get some shape to this. So I'm going to put a 1 in there. And I'm going to put a 1 into my function here. 1 squared is 1. So that's another point. So that's 1, 1. Please don't connect those lines because it's a U shape. Grab another one in there. Put 0. Just keep working your way back this way until you find the vertex. Some people are like, I already know where the vertex is. If you did, great, graph it and then make it. But if I put 0, 0 squared is 0. So then that's going to give me this one. Then I'm going to keep working. You can see that's not a line. Well, if I put a -1 in there, well, what is -1 squared? Ooh, that's +1. So if I want -1, ooh, I see my symmetry here. Okay, that means I should be able to, when I put 2 in, it should be outputting symmetrically across from my first dot. Now when I connect this, it's going to come down and it's going to go up and it's going to keep going like that. And when I'm done, I can erase that. I got to take my line, and if you made that line, get rid of that dirty thing. It should not stay on your graph, okay? And that is the graph. Now I can use my graph to evaluate, but it's always easier. I'm going to get rid of some of this stuff here so I can evaluate my graph. And I'm going to get rid of that. And there. And what I'm going to do is I'm going to take a blue dot. I'm going to say 6. Which one does 6 fit into? Does it fit in piece 1 or does it fit in piece 2? Well, 6 is greater than 2, so 6 has to come into here. So to evaluate that, it's 3 times 6 minus 5. Well, that's what? 18 minus 5. And 18 minus 5 should be outputting 13 for me on that one, okay? And then the last one, I got to say 2. Well, which one does 2 fit into? Well, this is greater than 2. This is less than or equal to 2. So the 2 has to come into here. So I'm looking at 2 squared, or 4 would evaluate that one, okay? And that's graphing piecewise functions. Please be careful when you run into your parabolas, when you run into squared terms. Sometimes your vertex doesn't have to be in the graph, just so you know. Okay? It's all just doing the mathematics, trusting your mathematics, and making sure everything goes into there really well. Hopefully, if you have any questions, today is a live session, so make sure that if you have questions, you log on and you ask Mr. Myers or myself. Other than that, that should finish up the lesson, and you should be able to go do try on your own homework and have a good rest of your day and weekend.